Welcome, welcome to Shennu Robotics. My name is Venu Annamdas. This video is a four four short videos, and let us see an overview of robotics in this first video. Robotics are one of the important growing fields whose applications are increasing not just in mechanical, aerospace, or electronics fields, but also in civil engineering industries. Let us see forward kinematics using Dinavit, Hartenberg, or simply DH techniques. According to a market research group, world's top industrial robotic manufacturer are as given below. These are some of the companies, but locally there are several companies available which can develop robots based on your industrial or personal applications. We are talking about robotic arms in these videos. We are not talking about humanoid robots as of now. There are many types of robots or robotic arms, such as serial robots and parallel robots. We restrict ourselves to serial robots because these are one of the most important industrial applicant robots. And one of such robot is called as SCARA robot, whose job is mostly, whose work experience is mostly in horizontal plane. The two pictures show the application scenario. For example, you want to write something on products, attach labels on your products, or do some assembly on horizontal in the horizontal plane, then you have to prefer SCARA robot. Or another example, drawing something in horizontal plane. The other type of serial robot can be the task space in vertical plane. That means end effector, the hand plays the trick here. You can choose whatever you want as links, joints, but the end, the hand, provides the key vital information which we have to identify if we have to apply robots in our day-to-day applications. For example, if you are planning to set up in a industrial environment where picking and placing of products is common, or drawing some circles, then you will have to plan your objectives starting from task planning. Task planning, then you have to simplify, you have to list down sequence of actions. Then you have to plan motion planning. The other two important are path planning and trajectory planning. Path planning is something to do with the motion of the robotic end effector from point A to point B. Suppose you want to draw a circle. So you can draw a semicircle first and then complete the circle. Or you can take break at several points along the circumference of the circle. So all these planning are called path planning. For all these path plannings, you may need simple dynamics equations, kinematic equations. Finally, most important thing is trajectory planning, which is process of which take equations of a given path as input and produces an equation of trajectory. Trajectory is planning of path together with time. It involves polynomial equations. As I said earlier, motion of your end effector from point A to point B or along a circle, circumference of a circle. So the robot will stop at selected points to complete its task. If you are asking a robotic arm to finish a circle, then it has to stop at intermediate points. So you have the choice of deciding at how many points it is going to stop or what is the speed of robot between the points, etc. etc. So the end effector depends on the position orientation of end effector depends on joint parameters J1 to J6 or J9. Today there are so many industrial robots which have 9 axis, but we limit ourselves to primarily 6 axis in all our videos. If you want anything more about serial robots or if you want to know more about the scalar robot, you can log on to the link provided here. The most important robotic tasks are use customized end effector. End effector is like your hand. Use customized end effector or robot hand for your specific application, such as drawing or for welding works. They don't have same end effector. In the same way, you have to determine position, coordinates and orientation of end effector by forward kinematics. So nothing to worry if you are not familiar, we will go through to understand what are these forward kinematics. And then finally, you have to develop algorithms of travel. As I said earlier, you have to know kinematic equations, some of the kinematic simple equations which you will be using in Python programs. Just like human beings have a brain and a hand to work, so your brain is like a CPU or a programming part which helps your hand to move. In the same way, robots need to be programmed, pre-programmed to do a repetitive task. If you look at any of the industrial robots, you can always find specifications attached to any robotic product. They they show you the type of joints, the axes of that robot. For example, if you look at a Fanuc robot, J1 provides a basic axis. If you look at their brochure, you will see the degree of rotation J1 can have, or J2 can have, or J3 can have, and so on. So these are all joint parameters. All these are joint parameters which you have to understand. If you have control or if you know joint parameters, then you can estimate end effector position, because the end effector is the main tool to finish your task. From point A to point B, to draw a circle, you should know all these joint parameters. For industrial robot, task of robot is to utilize end effector, as I said earlier, for repetitive work such as pick and place, printing, or painting, or component assembly. Now let us see definition of forward kinematics. It's the arithmetic operation where inputs are joint parameters like angles and displacement, and output are position and orientation. This is another example of six-axis robot. As I said earlier, end effectors can be anything based on your application. If you are planning to do welding, then you will have different end effector, and if you are using a painting, you will have a different end effector. So just like your wrist motion, the robot arm comes with the all types of wrist actions, wrist yaw, wrist roll, wrist pitch, and in the end you can attach end effector to the faceplate. So if you look at this picture, it provides you where you are going to attach your end effector. So all these J1 to J6 are usually provided in the brochure of the robot. So if you go to any shop and pick up a brochure, you will find information about the degree to which a J1 can rotate or J2 can rotate. Based on your requirement, you can buy a robot. the position and orientation of serial robots. Basically, you can think of 6 different positions.